Okay, hello again. What we're going to try to do today in this rather primitive video is we're going to try to finish up chapter 5, and we're going to try to, we're looking for equations involving rational expressions. So this is the last section of chapter 5 in your workbook, or you can also find it on your PowerPoint. So we're going to ask ourselves, well, what does that mean to solve a rational equation? Well, since we're dealing with an equation, we means that we're actually going to solve this equation. We're going to solve for the variable. So, for example, in example 1, we have here 5 over 3 minus 3 over 2x is equal to 3 over 2. So we're going to use a technique that's called clearing the denominator. Because when you look at this, it looks really, really complicated because it involves something that appears to be fractional. So what we want to do is we want to get rid of that fractional element. So we're going to do that by a technique called clearing the denominator. So what we're going to look for in the denominator here is we're going to look for the lowest common denominator. And in this case, we see 3, 2x2. So the lowest common denominator is going to be 6x. And what we're going to do is we're going to multiply through the whole thing by 6x, or 6x over 1 to keep things tidy. So we have 5 over 3 times 6x over 1 minus 3 over 2x times 6x over 1 is equal to 3 over 2, 6x over 1. Now remember, you have to multiply it through the whole thing, including what's on the other side of the equality sign. And then we can start canceling. So here we have 3, 6, so that's 2, so that's going to be 10x. Here we have 2x, and then 6x. Well, the x's cancel out, and that 2 goes into 6 3 times. So that'll give us minus 9. And then we have 2, 6, 3, and then we have the x there, and that'll give us 9x. So here now we have 10x minus 9 is equal to 9x. And now we have a very, very simple algebraic equation that we can solve just like any other algebraic equation that would be of this form. So we just go about solving for x the way we would normally solve for x, and we can go minus 10x, and we have minus 9 is equal to negative x, and this implies that x is equal to 9. And that's our final answer. So as you see, we're not simplifying this, we're actually solving it. And that is why this particular technique works, because we're solving something, and that's why when we multiply it through by the lowest common denominator, it clears the bottom of our fractional element. Okay, now let's look at example number 2. Well, here it's a little bit more complicated because we have a lot more stuff going on. So here we have 2 over x plus 3 plus 3 over x minus 3 is equal to negative 2 over x squared minus 9. So what I'm going to do to keep things tidy is put things in brackets here so I know what's going on and I don't confuse things. But well, we're going to do exactly the same thing in finding lowest common denominator that we have in the past when we were when we were looking at the expression. So what we're going to do is we're going to factor the things that can be factored. And indeed, this can be factored because it's the difference of two squares. Okay, so we have that. So now we're going to list all our possible factors. So here we have x plus 3. We have x minus 3. We have x minus 3, x plus 3. So we want to see what's the highest power. So we have the x plus 3. Well, we have an x plus 3 here, x plus 3 here. So all we need is the x plus 3. And that's the highest power of x plus 3 is the first power. Now we have x minus 3, or we have an x minus 3 here and x minus 3 here. And it's the x minus 3, the highest power there is 1. So this is equal to our lowest common denominator. So now we're going to use this, okay, to actually solve this problem or simplify this problem so it can be more easily solved. So what we're going to do is, again, for tidiness, is I'm going to put that over 1. So I'm going to erase some of this stuff so to make it clearer. Now that we know what the lowest common denominator is, and I'm going to multiply everything through by this. So I have now 2 times x plus 3, and then I have x plus 3, x minus 3, and then I have the next term, 3, x minus 3, times x plus 3, x minus 3 over 1, plus 1 is equal to negative 2 x plus 3, x minus 3, and then multiply that by x plus 3, x minus 3, and I'll put it over 1 for tidiness. So now I start doing the same thing that I did for the other problem. So I'm going to look at the factors they have in common. So here, and that's the one that's left over. I can erase this now. So now I have 2x minus 3 for my first term. Then I do similarly for here. And then I have 3x plus 3. And then here, this whole thing cancels out. And then it's equal to negative 2. So now I have something that looks a little bit more manageable. And of course, so now what I'm going to do is use my distributive property to finish this up, combine terms, and solve for x the way I would do a normal algebraic equation of this form. So I'll just go about doing that. So I have 2x minus 6 plus 3x plus 9 is equal to negative 2. So I combine my terms here. So I get 3. And I combine my terms here, and I get 5x. So now I have an equation that looks like 5x plus 3 is equal to negative 2. Wow, isn't that manageable? So now we just solve for x the way we would normally solve for x. So I'm just going to rewrite it here. 5x plus 3 is equal to negative 2, minus 3, and then a 5x is equal to minus 5, and therefore x is equal to negative 1. And there is our final answer. Now let's look at example number 3. So here we have 5 over x plus 2 is equal to 11x plus 1 divided by x squared plus 7x plus 10 minus 12x plus 5. So I'll just bracket things for neatness, okay, just to know what I'm working with. And now, well, we know that, again, we're going to find the lowest common denominator. And again, we have to factor and list all the parts we have. So in this case, if we factor this here, we get x plus 2 times x plus 5. And of course, I check it. The last term, to see the last term, I multiply it. 2 times 5 is 10. And if I add these two terms, I get 7. So it looks good. And so now I'm going to list my denominators, factors. So I have x plus 2, I have x plus 5, I have x plus 2, I have x plus 5. So now I'm going to look at it, okay, and I'm going to see, well, I'm going to multiply it through by that. So I'm going to go 5x plus 2 times x plus 2, x plus 5, and I'll put the 1 there, as I said earlier, for tidiness, is equal to 11x plus 1 over x plus 2, x plus 5, since they're exchangeable and it makes it easier to see what's going on. Over 1, and then my last term okay. So now I start canceling stuff out because now I have it in factor form, which means we can now clear the denominator. And then now we can write an equation that is now more manageable than what we had earlier. So there we have it, and now we just solve for x the way we would do any type equation of this form. So I will just proceed to do so. Distributive property, so I get 5x plus 25 is equal to 11x plus 1 minus 12x minus 24, and then I put together the common terms. So I end up with 5x plus 25 is equal to negative x minus 23. And then finally, I end up putting everything. Remember, choose a side where you're going to put your variable, choose a side where you're going to put your constants, and then you find you get 6x is equal to negative 48, and this means that x is equal to negative 8. Now, on your PowerPoint, you will find that on the answers that you also should check this, okay, if you can. Now, of course, checking this is really rather complicated in this case. So I'm going to leave that to the reader or leave that to the student, but what you want to do is you want to go to your original equation where it looks like this and take the x is equal to 8 and put it into your original equation. So everywhere you see an x, you will put an 8 and then proceed to see if you get the same answer on this side as you get on this side. And again, on your PowerPoint, you will see that I actually worked it out, and indeed it did work. In our last problem, we saw a situation where the x actually does work when we plug it back into the equation. Because if we look at the last equation, we see, or the last example, I mean, we see that the denominator, if we put any number in for x, and in the case of our last equation, it was -8, we will not get 0 in the denominator. And that's a good thing, because that's exactly what we do not want. But let's look at this next example. So we're going to look at example number 4. So we're going to solve 3 plus 1 over x is equal to 10 over x squared, okay? So just by looking at this, and again, I'll put the 1 there so we know the difference between what's our numerator and what's our denominator. So what we're going to do is we're going to see what our lowest common denominator is and clear our fraction and clear our denominator. So lowest common denominator is equal to x squared. So as before, multiply through x squared over 1, and then this is okay. This one, we got rid of one of the x's, and this one is equal to 10. So we end up with something that looks like this. Now, of course, in order to solve this, as we learned earlier with quadratic equations, we have to put this into standard form. So I have to move that 10 over and set it equal to 0. And then, of course, I could factor. So what I do is I factor. And I find that when I factor this, after going through the whole factoring technique that I showed you earlier, because I can't simplify this, so I'll have to use the AC method that I showed you earlier. And so I find that the factors for this one are 3x minus 5 and x plus 2 is equal to 0. And then, based on the rule which we learned earlier when we were solving quadratic equations, we set each of the parts equal to 0. So we have 3x minus 5 equal to 0, and we have 2 plus x plus 2 equals to 0. So this means x is equal to -2. And then on the other side, we have x is equal to 5/3. So now we have this and this. So we want to now, and this is the reason why it's often so important to check, even if it's just a spot check. So, for example, in this one, okay, if I put, okay, so let's look at this for a second. So if I put in -2, that looks good. okay, and I put 2, 4, that looks good. And if I put in 5 over 3 here, that's good. And if I put in 5 over 3 here, that's good. And so what we see here is that neither of those give me 0 denominators. So none of these solutions give me 0 in the denominator, so therefore both of my solutions are good, and that means that I can write my solution set as -2 and 5 over 3, and that is my solution set. But there are other situations where that may not happen, and you may end up with a situation where you get a 0 in one of these, and that will mess up the whole thing, and that means that that solution is not a solution. So let's look at example number 5. So example number 5, we have x minus 6 over x plus 3 is equal to 2x over x plus 3 plus 2. And we find that the lowest common denominator in this, because again, I'm going to do this in here. We find that our lowest common denominator is x plus 3. So now we're going to clear the fraction. So we have x over 1 minus 6 over x plus 3, x plus 3 over 1 is equal to 2x over x plus 3, x plus 3 over 1, and then plus 2 over 1, x plus 3 over 1, and now we proceed to x plus 3 minus 6 x plus 3 is equal to 2. This cancels out, so we end up with just 2x there, and if we made a mistake here, that has to cancel out, so it's just minus 6, and we have 2x plus 2 times x plus 3. So there we have it. Almost forgot about this guy over here. So you want to make sure that you are careful and you cancel out what needs to be canceled out. So now what I'm going to do is my distributive rule. So I have x squared plus 3x minus 6 is equal to 2x plus 2x plus 6. So there I have that. And then, as usual, what I'm going to do is we have to set this equal to 0, so I'm going to have to move all the stuff. I'll bring these two together, make that 4x plus 6, bring everything over that needs to be bring over, and I end up with an equation, x squared minus x minus 12 is equal to 0. So this is not too difficult to factor, unlike the previous one where you have to use one of the more sophisticated methods to factor it. This one is fairly straightforward, and you have x plus 3, x minus 4 is equal to 0. So now, again, I'll just quick check. 3 times negative 4 is negative 12. 3 minus 4, add them together, I get minus 1, so it looks good. And then I set each of these terms equal to 0. Is equal to 0. So I set each of these terms equal to 0, and then I solve for the x, and I get x is equal to -3, x is equal to 4. So now I'm going to look at this, and I'm going to go, uh-oh, problem. If I put in x is equal to -3 back into my original equation, what's going to happen? It's going to be 0 in the denominator. That means that this is undefined, and this is no good. But this one is fine, because if I put this in the denominator here, I'll get 3 plus 4 is 7, and this denominator I'll get 4 plus 3 is 7, so that's good, and that means that I have a denominator that's not crazy. Now, of course, I can continue on checking to make sure I get the same thing on this side as I get on this side to make absolutely certain. So it's very important that if you do not have time on a quiz to do an extensive check, make sure that you check that the denominator is not undefined, or gives you an undefined term. Now we're going to solve something a little bit different. We're just going to solve for some variables. And as we did earlier, we're going to learn a little bit more about these kind of things in situations like this. And these were called literal equations. And that means we have, here's a situation in number 6, where we have a plus 1 over b is equal to 1 over x. So here we want to solve for x. So again, we do the same sort of thing. We want to look for what is the lowest common denominator and clear the denominator. We want to look for the lowest common denominator and clear the denominator. In this case, the lowest common denominator is a, b, x. So we multiply the whole thing through. So even though we have just letters here, we go through the same process as it would be for numbers. So in this case, we have 1 over a times a, b, x over 1 plus 1 over b times a, b, x over 1 is equal to 1 over x times a, b, x over 1. And now we do the same thing we did before, that we did with numbers and variables. So we have the a here and a here, bye-bye a. We have the b here, bye-bye b. We have the x here, the x there, bye-bye. And now we rewrite it, okay? So here we have bx plus ax is equal to ab. So now, as we did when we were looking at literal equations, we pull out the x, and we end up with ab plus a is equal to ab. And then we divide b plus a, b plus a, and then we get x is equal to ab over b plus a, and we see if we plug in where the x is, it's not going to give us 0, so we know that we are going to be okay. So this completes chapter 5 and all the examples that are in chapter 5. So the next chapter, of course, will be chapter 6. Okay, thank you very much. Thank you for watching.